we are here. I am Alex Williams, founder and publisher of the New Stack, and we have a great lineup today. I'm so excited for these demos. I'm going to make some quick introductions and we're going to get right into it. So why don't we just start off, and I will quickly say hello to everyone. First up for our demos will be Michelle Noorali. And Michelle is a senior software engineer at Microsoft, and she's going to be doing a demonstration of the open service mesh. Hey, Michelle.
Hey, Alex. Thanks so much for having me here today. I'm so excited to talk about OSM.
Awesome. So we also have joining us Phil Prasek. He's a principal product manager at Upbound, and he's going to be doing a demonstration of Crossplane. Hey, Phil.
Hey, Alex, great to be here.
And next up will be James Roper, a cloud architect at Lightbend, and he'll be demonstrating Cloudstate. Hello, James.
Good. Hey, how are you going?
Great. In from Australia. It's a little bit early there. Thank you for joining us at this early hour, James. And we have Torin Randall, Vice President of Open Source, co-creator of the Open Policy Agent. Torin is with Styra, and he's going to be demonstrating the Open Policy Agent today. Hey, Torin, thanks for joining us.
Thanks for having me, Alex.
And Ryan McKinley of Grafana Labs, who will be demonstrating their observability platform. Ryan, thank you so much for joining us. Let's get right into it. Starting off with Michelle.
All right. Hey, everyone. Thanks so much for joining us today. I'm going to talk to you about OSM. How you can install OSM is by grabbing the CLI from the GitHub releases, or from Homebrew, or from Building by Source. All you have to do to install OSM is run OSM install. This essentially installs something we call a control plane. So there's some components running in the OSM namespace. Let's see. Pods-n, some system. All right. So this is what we call a control plane. So for folks who are not familiar, Service Mesh helps you extract all of the application networking related logic from your core business logic or your core application. And we just dump those rules and configurations into a sidecar proxy that runs next to your application. We are Envoy based, so we use the Envoy proxy. This control plane goes ahead and it reads any configuration that you want to apply that's related to your application networking for your applications. So like things like traffic shifting, traffic splitting, access control rules, figuring out what services can talk to one another, MTLS, things like that. It'll read what you want to do, and then it'll apply those rules to your proxies that are running in your cluster next to your application. So the bulk of the control plane lives in this thing called the OSM controller. It does the Envoy proxy programming. We also have this Prometheus instance and this Jaeger instance that are also running in our control plane. This is for monitoring and tracing. Those are optional. You don't have to have them if you don't want to. So OSM is built natively against SMI. SMI, Service Mesh Interface, is a standard interface for service meshes on Kubernetes. It defines this basic set of service mesh features that most people want from a service mesh. So we've implemented those. We program these Envoy sidecars, and I kind of want to take you through what the workflow looks like. So we've installed the control plane. There is a manual demo guide in our repo. We're going to go ahead and install an application, or a set of applications rather. So we're just going to create these namespaces to do that. This basically replicates some real world example. And then to actually do the sidecar injection, to inject your application pod with the Envoy proxy, you have to apply some sort of annotations to the Kubernetes namespaces that your applications live in. We have a convenience command that does that for you. So that's the OSM namespace add command. This basically ensures that any pod that gets created in this namespace does get injected with the sidecar proxy. And so all traffic, instead of going to your application, will be rerouted through your proxy, and the proxy is going to deal with any inbound, outbound communication. All right. So now that we have the namespaces set up, let's go ahead and install the applications. All right. So what we have here is a book buyer, which talks to a book store, and the book thief tries to steal books from the bookstore, and there's a book warehouse application. The bookstore talks to the book warehouse application to restock its books. So let's go ahead and see what these look like. Right, so we know that 2 of 2 containers are ready. That's one is the proxy, one is the application container. All right, so now that we have some applications, they're all set up with OSM, let's go ahead and do things let's go ahead and view the UIs and see what we can actually do with OSM. There are lots of things you can do with OSM, but I kind of wanted to display access control. So for each of the UIs, for each of the applications, we have a UI. You can use a port forwarding script that we have in our repo to actually port forward to all of the example applications. So we're going to check out these UIs. We're going to see what they're actually doing. So the book thief is in this UI right now. It is not talking to anything. No counters are being incremented. No books are being stolen. In the bookstore, same thing. In the book buyer, same thing, nothing's happening. All right, so OSM has two modes, essentially. It has permissive mode, and it has something called non-permissive mode. And by default, if you install your applications with OSM and configure your control plane with all the default settings, then none of your applications are going to be able to talk to each other until some sort of policy is applied to ensure that a source can talk to whatever service you want it to talk to. So permissive mode actually lets all of your applications talk to each other. So for a lot of people, being in the non-permissive mode is really disruptive. So there is a way to reconfigure that, but I'm in non-permissive mode. So none of my applications can talk to each other until I apply this traffic target policy. So I'm going to go ahead and do that. So I believe it lives in this thing called this access directory. We're going to go ahead and apply that just to let it run for a few seconds while I actually show you what it says. So this is an SMI traffic target policy. It basically tells you that these sources can talk to this destination on this set of routes or rules that are configured. These are SMI policies. These are the APIs that SMI defines. This is one of them is called traffic target. And if you want to configure a specific set of rules and routes and headers and things that are allowed or not allowed to talk to your services, you can do that via the HTTP route group spec, which you then reference in the rules. So traffic target allows you to do access control. Just to recap, you have a source, talks to a destination. Once you apply this, things will be able to talk to each other. So here we should see some counters incrementing, which they are, and it's roughly the same amount on bookstore and book buyer because we've allowed the book buyer to be able to talk to the bookstore via an SMI policy. Now, the book thief is an application that is pretty mischievous and it likes to steal books, but it has promised us that it is no longer going to steal books. So we're going to update our traffic access policy to allow the book thief to talk to the bookstore as well. So we're going to go ahead and apply that here. And then we're going to wait a few seconds. And while we wait, I'll go ahead and show you all of the resources that you need to kind of get started. smi-spec.io is a place where you can learn more about the spec. And openservicemesh.io is where you can learn about OSM. Again, we are Envoy-based, SMI native, and we are really looking to build a project that is very simple and easy to understand and easy to install. These are aspirational goals, but the idea is this is a complex piece of technology, and we're trying to be as opinionated as possible to give people who want service mesh features those features without too many knobs and too many knobs to turn. All right, so here we can see now that Book Thief, its counter is also incrementing, so I can talk to the bookstore. So that's all I have for you today. Please check out the resources that I mentioned. If you have any other questions, feel free to reach out. I'm available via all of the regular channels, Twitter and GitHub and email. Thank you.
So next up, who do we got coming up next? Let's see over here on the board. We have Phil, Prasek, Principal Product Manager at Upbound. Phil, take it away. Lightning time.
All right, thanks, Alex. Hey, I'm Phil Prasek with Upbound, and excited to talk with you about composing your own cloud APIs with Crossplane to eliminate infrastructure bottlenecks and deliver your apps faster. So we all know the path from dev laptop to production has a lot of hurdles along the way we have to overcome, including infrastructure bottlenecks and security pitfalls. There's often multiple tools and imperative pipelines that are kind of cobbled together with multiple management models and state representations. It can be hard to master the interactions and failure modes across those. So you take that in combination with inconsistencies across environments, you're creating bespoke configs for the first time. You can introduce security issues without really realizing it. And then dealing with secret distribution can often be way more insecure than we want, especially with ticket op systems. So, it's not surprising with all of this going on that you have conflicting issues that are often found at deploy time, resulting in additional cycles that basically can introduce significant delays into getting your app into production and with a weaker security posture than you might like. So what are we looking for here? We have cloud providers with hundreds or thousands of APIs and GUI portals on top, and we can click around and provision the infrastructure that we want. But to get something more repeatable, we put IAC tools into imperative pipelines, and that's been a really big step forward. But it has a lot of the limitations that we just talked about. So what we've found is that people want a more integrated cloud-native declarative management approach, like you get with Kubernetes core resources, like deployments and services, but for all of your infrastructure, all of your cloud services. And so we've seen these service operators come onto the scene that basically bridge the low-level cloud APIs into the Kubernetes API, effectively providing the assembly language of infrastructure into your Kubernetes platform. But they don't basically provide the next level of abstraction, and they don't provide a clean separation of concerns. So some people might say, hey, forget about infrastructure entirely. I just want a platform as a service, and those tend to be more vertically oriented, and they might not be as flexible or customizable as you might like. So what we're really looking for is the ability to compose our own platform abstractions from these underlying cloud service primitives and offer them up to our teams so that they can get their apps into production in a more frictionless way. So what if you could define consistent APIs for your platform across dev, staging, and prod with all of your best practices and security policies baked in without writing any code, just using idiomatic Kubernetes YAML. So you can enable your app teams to just keep control apply the infrastructure that they need to eliminate infrastructure bottlenecks, avoid security pitfalls, and deploy apps faster. So what we're going to look at today is how you can use Crossplane in Upbound Cloud with the AWS reference platform to provision a Postgres instance using existing tools and workflows in a resource claim that provisions against a self-service API that's basically defined by our platform ops and SRE team to provision a composite PostgreSQL instance that's composed of multiple cloud service primitives from the Crossplane AWS provider. So with this, we're going to dive into the Upbound cloud, which is basically powered by Crossplane, and we're going to navigate to our organization, and we're going to go to the user console. And so here we're going to pick the platform that we want, dev, and then our team workspace. And we can see that we basically have a curated set of self-service APIs with all of the best practices and security policies baked in. So I'm going to come and provision an awesome DB, and it has some settings here that I can just go ahead and leave the default for. And that's going ahead and provisioning that. Now, what I can also do is I can connect using the CLI to kube control. And so I already have my access token here. So I'm going to go ahead and just drop these in. And this will connect my kube control into my dev team workspace. And then what I can do next is go ahead and kube control apply. A database claim to provision an additional database from kube control with all of my best practices and security policies built in. And then if I do a kube control get claim, I'll be able to see all of the resource claims for my platform APIs, and we can see that we have both in the UI here and in kube control the ability to see that. And so if we take a look at our RDS console and we do a quick refresh, we can see that we do in fact have two databases being provisioned and they're in the creating state. So all of that's great, but we might ask ourselves, how all of this magic is possible. And so if we take a look at the AWS reference platform for Kubernetes and data services, this contains the Crossplane configuration that basically defines all of our compositions and API definitions that we just saw. And in this case, it depends on the Crossplane provider AWS of that particular version and this version of Crossplane. And then if we go back and just take a look at how easy it is to define a new API, we basically have a composite resource definition. You can think of this as the API schema definition. And we call this an XRD. It has an optional set of UI annotations. And so everything that we saw in the UI was rendered dynamically from this metadata. And then we have here the API definition itself, which is very straight ahead. And so with that API definition, we basically have a composition here. You can have multiple compositions for multiple classes of service. And what this does is basically composes together using the API schema as input, multiple cloud service primitives. So we have a DB subnet group and an RD instance, and then that's basically parameterized with the API schema using a patch overlay here. And so with all of that there, we can basically provision from both the UI and from kube control using Crossplane, which is what Upbound Cloud is powered by. So what we just saw here is being able to provision a PostgreSQL instance using our existing tools and workflows to provision against a self-service API that was defined by our platform ops and SRE team that's composing multiple cloud service primitives from the Crossplane AWS provider. So if you want to learn more, check out Crossplane.io for the open source CNCF project that's targeting 1.0 by the end of the year. Or Upbound.io, which is the fastest way to get started with Crossplane. We got a couple talks at KubeCon, so check those out. Drop by the booth and say hi. And all the stuff that you saw today is going to be in our new reference platform support that's launching on November 10th. So check out the link here and look forward to talking with you. Thanks.
All right, thanks, Phil. Before I go any further, I want to give a big thank you to the KubeCon team, the Cloud Native Computing Foundation. Thumbs up, lightning bolt, lightning, lightning, lightning. That is what the KubeCon is going to bring, some excitement and energy to the old Cloud Native Computing realm. So up next, we have the one and only James Roper of Lightbend. Take it away for this demo of Cloudstate. Hey, James.
Hello, thanks. So my name's James, and I work for Lightbend as a cloud architect. So today I'm going to be talking about Cloudstate, which is an open source serverless framework that we've created, which addresses a gap that we saw in the serverless market, where serverless was primarily dealing with stateless functions. But of course, most applications have state. And when you just kind of delegate that state management to a database, you end up still having to deal with a lot of the things that serverless are meant to solve for you, such as, well, how do you deploy and scale your database, and how do you manage your consistency concerns and things like that. So Lightbend, the company I work for, we produce an actor framework called Akka, and Akka is really good at distributed systems, which a serverless system is a distributed system. So what we did is we turned around the state management model, we turned it on its head. Rather than an application having to go and fetch its own state from something else, it's provided with its state by the framework. And what you do is you deploy these entities which hold the state, and because the framework understands what sort of entities they are, what your consistency concerns are, your scalability concerns, it can manage that state for you and deploy those and scale those and ensure they are resilient as necessary. So I've got a demo app running here. csqa.app is the URL, so you can go and have a look. It's a conference question and answers application. So you can select a presentation and ask a question. So this isn't a question, but I'm going to ask it. Now, I haven't implemented all the functionality yet, so I asked that, but you can't see the question yet. If we hit refresh, you can see it there. And if anybody else wants to go to CSQ&A app and go to the Cloudstate presentation, we might see other questions appearing soon when we hit refresh. Okay, so you can vote on questions. Of course, I haven't implemented the thing that goes and updates, sends the update back, but so I have to hit refresh each time. But you can see that working there. Now, Cloudstate runs in Kubernetes, and so the thing that is running this is called a stateful service. So I can get stateful service. You can see my Q&A app there. If we go and have a look at the pods, you can see I've got it scaled to 3. It does auto scale, but just for this demo, I've got it set to 3 instances. And the way I've implemented this Q&A entity is it's implemented using something called a CRDT, a conflict-free replicated data type. So that this presentation, which is represented by a single entity, is that entity is replicated across each of those 3 nodes. So whichever node handles the incoming request is going to already have the data there. And one nice thing about CRDTs is each node can function independently. They don't need to all coordinate their updates. We can have everything, each node can be concurrently making updates without needing to pause and have any coordination to make sure that those updates occur, and the CRDTs gossip those updates between the nodes to ensure that they eventually all agree and come up to date. So having quickly a look at the code, a Cloudstate service is implemented using gRPC. So we've defined a gRPC service here. We have an ask request here, and we have a watch request here. So the ask is what's used to ask a question as well as to vote on question, and watch is used to get the state. So we can see here, here's the implementation. I've written this in JavaScript. We support quite a range of languages, including Java, Go, Python, but I'm using JavaScript today. So we can see if we don't already have the question being asked in our state, but then we will create a new G counter. So a G counter is a grow only counter, which is a CRDT that you can have all the nodes incrementing at once, and it will guarantee that every increment is applied. And then once we've ensured that the question is there, we increment it by 1. So this watch call here, you can see right now all I'm doing is I've got this helper function to copy the questions, and I return that as as the questions. What I haven't done is implemented the functionality to be able to stream updates as they happen. Now, just to show you something, this watch request actually returns a stream of questions. So it will return the updates as they happen. So let's just code that now. I'm going to set an on-state change callback. I'm then going to find the diff of the questions from the last time that the callback was executed. And so then I can use that to say if there are any questions that have had their the number of votes updated, then I'll return that. And so that's all I needed to do to be able to do this. And so this on-state change callback will be executed every single time a change is made, either locally or on another node. So now I'll just build that and push that to my server. And here's the deployment descriptor from my server. So I'll just change that tag to latest, and then I can kube control apply that, and we should see that that's starting to update. And so if I'm lucky, I'll hit one of the updated nodes soon on here, and we'll be able to start seeing updates stream live. So if yep, that worked actually then. So you can see those, and can I ask more questions? And so if somebody else wants to jump on there and start making changes, you'll be able to see them on my screen. And so, yeah, that's a quick demo of Cloudstate showing the CIDT. So the CIDTs are replicated entities. We also have event-sourced entities which get sharded across the cluster of nodes as well. And the idea behind Cloudstate is you choose the right state management pattern for your use case. So cloudstate.io to check it out. Thanks.
So here I am. Here we go again. Our next demo is Torin Randall showing us Open Policy Agent. Torin, the buzz is about OPA. Policy is hot, hot, hot. Take it away. We want to hear all the buzz about OPA. Thanks, UConn, for making this show happen.
I wanted to do a demo that had a bunch of Dune references sprinkled into it. Unfortunately, it's 2020 and we can't have nice things anymore. So the OPA Dune demo is getting pushed back to 2021. So if you want to hear about Open Policy Agent or OPA and Dune, you gotta wait till then. If you're not familiar with Open Policy Agent, or OPA, as we like to call it, what it is a open source, general purpose policy engine that allows you to essentially unify policy enforcement across a wide range of software. We like to say that you can use it in any system, in any service, at any layer of the stack. So regardless of whether you're talking about enforcing rules during CI/CD, or you want to put safeguards and guardrails down on your Kubernetes cluster, or you want to protect access to sensitive microservice APIs, OPA provides a single reusable building block that allows you to write and enforce important rules that govern who can do what in your system. And so to talk about OPA today, I thought I'd use a popular use case around microservice API authorization. And to do that, I've got a little demo application here, which basically serves employee profiles for a company. So this is an application that's built on top of sort of a microservice architecture. So you've got a service that's responsible for employee details like name and manager, and even sensitive data like social security number. You've got a review service that stores and manages all the performance reviews, and we've even got a rating service that has a little numerical score for every employee. And then on top of all of that, we've got a landing page service that stitches everything together and serves the page to the browser. And so the way that this works is that when my browser accesses the application, the landing page goes out and it gathers the information from the detail service and the review service, which goes to the rating service and so on, and then it stitches it all together and it sends it back to my computer. Now, what we want to be able to do is put down checks, authorization rules, and that get enforced at every hop in this graph. So in the landing page reaches out to reviews, we want to be able to verify that the caller and the user is allowed to access the performance review. And the same thing for details and the same thing for ratings. So the way that works is that each one of these services has been changed, or it can call out to OPA to ask for those policy decisions. And when they do those call outs, they provide certain information like the source service and the target service and the HTTP method and the path. And they can supply whatever information they want, including the user that's making the request, the authenticated user. And so using this kind of setup, we can show a bunch of different policies. We can show a service graph policy that controls which services can talk to which other services. We can show an application level policy that says that, for example, managers can see performance reviews, but coworkers cannot. And we can also show how OPA lets you write policies that generate not just Boolean yes/no decisions, but also non-Boolean decisions, like controlling access to specific fields and API responses. But this is that demo application that I was talking about. You can see on the right-hand side, the demo app is up and running. We can see Dracula's profile here. You can see all the information about them. On the left-hand side, you can see an example of an OPA policy. So all of the microservices that make up this application are talking to OPA, and they're asking for policy decisions. And OPA is basically reading the policy off my local file system and rendering it to produce decisions for the application. And so to understand what's going on right now, everything's visible. We can see all the details, like the social security number, the performance reviews, even though we're not signed in at all even. And so what this policy basically says right now is simply that by default, requests should be denied. So by default, allow is false. However, the request should be allowed if the service graph policy allows it. And so to understand what's actually going on under the hood, we need to switch over to a different policy file that's being loaded into OPA. And so this is that service graph policy. And you can see here that what we've done is we've kind of encoded a little data structure into the policy that says which services are allowed to talk to which other services. And so that's encoded into the policy. Obviously, it could also be loaded in just as raw data, but I've done it inside the policy just for demonstration purposes. And then below, we have some rules that interpret that data structure in order to make the decision. So right now, we allow basically external access to the landing page, but then within the individual microservice topology, we consult that data structure to make the decision. Now, one thing you'll notice right here is that we've said that by default, allow is true. And so that's why everything's rendering. And so you typically don't want an authorization policy that's allow by default. You typically want to deny by default. So I'm going to fix that, save that file. And when I refresh the page, now you can see that the performance reviews are no longer loading. The reason for that, of course, is that inside my little service graph here, I haven't allowed the landing page to talk to the reviews service. And so if I go and I update the service graph and I save that file and refresh the page, the change takes effect immediately. Okay, so this is like a simple policy. It just demonstrates the fact that you can reload the policy on the fly and the changes take effect basically immediately. So OPA is able to basically download policy or load policy off disk and then reload it without any interruption to the service or the policy engine itself. So I'm going to restore that and save the file, and we can see that everything's loading correctly now like we'd expect it to. Now, what we want to do on top of this, though, is implement something that's a little bit higher level, something more like application level. And what we want to say basically is that the only people that can see, say, Dracula's performance reviews are Dracula himself, as well as Dracula's manager, Janet, and then maybe people from HR like Ken. And so again, I've encoded some data into the policy. I've encoded an org chart into this policy. So I've said that Dracula is managed by Janet. He's got some roles. Alice is also managed by Janet. She's got some roles. Janet's just in engineering. She's a manager. And then Ken is from HR. And then the policy below here, again, interprets that data. And what this is basically saying is that if the resource being accessed is not private, then anybody can see it. Otherwise, we grant access to read our own performance reviews, our subordinates' performance reviews, and we kind of have an exception in here for HR. Now, in order to get this policy enforced, I need to hook it back into that entry point above, right? Because all that's being enforced is the service connectivity rules. And so I can do that simply by referencing the policy in the namespace that it was defined in, org chart, and then referring to the allow rule here. And so now this allow rule says basically deny by default. However, if the service graph policy allows it and the org chart policy allows it, then allow the request. And so if I refresh the page now that we've got the org chart policy in place, we can see the performance reviews again are hidden because we're not signed in. But if I go through and say I sign in as Dracula himself, he can see his own performance reviews. If I sign in as Janet, who's his manager, she's able to see the performance reviews. But of course, if I sign in as just Alice, who's his coworker, she's not able to see it because the policy doesn't allow it. So this is an example of a policy that's more kind of like application level, and this is a use case that we see more and more people adopting OPA for today. One other thing I just want to kind of show here is how you can generate non-Boolean policy decisions. So below here in this file, I have a rule called PII. And so what's happening is that details service is querying for the PII decision, basically, whenever a request comes into it. And in this case, what we're saying is that the social security number field is considered PII. It should be sensitive if you're not the user requesting your own details, or you're not from HR. So even Janet, the manager, shouldn't be able to see the social security number. And so if I've uncommented this rule, and so if I refresh the page now, you can see that the social security number got blanked out. If I log in, say as Ken from HR, then of course everything shows up. So this is just an example of a different kind of rule that you could put in place. You could obviously generate arbitrary JSON data here. So now I've got an array with 2 strings inside of it. And if I sign out, and we see that the birth date now gets blanked out. So this is just another example of a kind of custom policy you could put in place inside of an application using a policy engine like OPA. So that's really what I wanted to show today. If you're interested in Open Policy Agent or policy-based control in cloud-native systems, check out openpolicyagent.org. We've got great documentation for the project that goes over all the different kinds of use cases around Kubernetes and Envoy and all sorts of other projects. And if you're just getting started, I recommend checking out the OPA Playground. This is an online environment where you can basically evaluate policies, you can test them out, can see what they do. And we have a library of policies in here that you can use to kind of get started. And so we've got examples for role-based access control in applications, Envoy-based microservice API authorization, as well as Kubernetes admission control when you want to put down kind of guardrails over what developers are doing inside of your Kubernetes clusters. So that's all I have for today. Thanks a lot, Alex, and I'll kick it back to you.
Thank you, Torin, for that excellent OPA demo. Up next to tell us all about Grafana observability is Ryan McKinley. Thanks again to the KubeCon crew, CNCF. Ryan, take it away. Give us some buzz.
All right. So thanks, Alex. I'm going to walk you through some new features in Grafana 7 and show you a bit of how some of the new ways that we're using Grafana to build a platform so that we can build better solutions coming along. So just for a quick background, I'm from Grafana, but I actually came to this from a very different world. So my introduction to Grafana was staring at a dashboard that looked a bit like this, and being, pretty frustrated with it. So went through a bunch of things and then found the tools that I'd say the cloud native people have built. And it's just works so much better than industrial tools. So that's a bit of my background and kind of where I think about Grafana in the context of kind of the world of technology. So the parts of Grafana that probably most people are used to is that you can see your data wherever it is. So, people in Kubernetes, mostly people connect that to Prometheus. We can see that data, can have your logs stored in Loki, other data from ServiceNow, and show it all together in one place, right? So if you have some enterprise feature plugins like, keep your data in New Relic or Datadog, Prometheus, and ServiceNow, with Grafana, we can pull that all together and show it all in a single place. Super powerful. In Grafana 7, we expanded the list of what data you can connect to and the structures for doing that. So this list goes on and on of where you keep your data and let you use that all in the same place. But as we all know, all data sources kind of have different capabilities, right? So if everything's in Prometheus, I have a very consistent way I can work with it. This dashboard is showing me within some home automation systems, I've got some data that's stored in Prometheus, some data stored in Graphite, some in Influx, and that's all graphing this data together. That is pretty powerful to be able to do that. But there's some features I may want to do with it. So here I'm going to take this, take that data, and in a different dashboard, this is maybe a little known feature, but super powerful, is I'm picking, rather than re-querying all that data to show a graph of these temperatures, I'm picking the dashboard data source here, and then saying of the other panels on this dashboard, I want to reuse that data. So within here, I can see graphs of that. Here, I set up my field configurations to say across everything, the units, what the minimum maximum values I want, and defining some thresholds. So this helps me color those. So that's really powerful, except has always been kind of a bit of a pain if you now want to switch to a different visualization that has different configurations. In Grafana 7, we move this so it's all in kind of one place that's reused together. So with that, I'm going to take another panel here. So this is saying, given that data, I actually want to see what's the difference across here. What's the difference between, say, the office and upstairs? So in this panel, I'm going to likewise use the same data. And in this case, I'm going to do a difference. So what's the difference between office and upstairs? And this, what's interesting, again, is note that the office data came from Prometheus and the upstairs data came from Graphite. So this is a feature I'm super excited about that essentially lets us add a minimum set of operations regardless of where you came from. So to blow through some more things here, in a similar idea, so that's if with data coming from anywhere, this is a new feature I'm super excited about where essentially there's no database involved. I'm going to actually just push data to Grafana and it can show it. So in this case, I'm going to send it one value for air quality index. Along with that, I can also send along, say, the units. So rather than configuring this in the UI, we can do it driven by our data. So even more complicated, the sort of full threshold side of things. So get a full threshold view here. So same thing again. I'm going to take this same data. I'll publish data that's Oakland and some other data that's from San Francisco. Again, this is streaming data to Grafana instead of it necessarily pulling it out. And again, I want to do the difference between Oakland versus San Francisco. So in this case, I'm going to reduce the fields to figure out what the last value I got and do a difference between Oakland and San Francisco. So the next one I want to show, so that is kind of an exciting thing to say that we now can see essentially handle event-driven operations from Grafana. So here, this may be a little subtle, but within this, I'm going to edit a dashboard. I'll save it. And you'll note that the dashboard behind it has also updated. So this is a new feature in Grafana 7.3, which is, I think, going to be released next week. There's a beta out now that you can enable. And we get live updates as the data changes. So, and with that, I will show you, I guess, conclusion here. The big goal of Grafana is essentially to allow you to have your data wherever it lives. Work with that. We can now extend our data configuration along with it, from the data sources. For Grafana 7, with this live feature, you can enable it in the custom INI, so enable live. And then from that, we can start to look at new features coming down the line that deal with data as it streams in instead of always querying for it. So thanks, Alex.
Well, that is it. I want to thank everyone for all these fantastic demos. And I want to keep thanking KubeCon and the CNCF for making this possible. These recordings will be available for everyone to see. We're going to get them posted as soon as possible. But in the meantime, I want to thank every one of my guests here for participating. Michelle Noorali, who was giving a demonstration of open service mesh. Thank you very much, Michelle. Really helpful to know that. I'm loving kind of the Envoy world beginning to really extend, and really you've embraced it and you're bringing new thoughts and perspectives to service mesh. So thank you for that. We have Phil Prasek of Upbound and showing us Crossplane. Thank you very much, Phil. And then we had Jason Roper, a cloud architect at Lightbend, showing us Cloudstate. Good stuff, Jason. OPA was next, and we heard from Torin Randall, who gave us a good demonstration of the open policy agent. And then we had Ryan McKinley, who just showed us Grafana Labs. So I want to thank who just showed us Grafana, in particular observability features. And Ryan is with Grafana Labs. But thank you very much. You are with Grafana Labs. That's correct. I get it. I want to make sure we're just right here. But yes. Anyway, so thank you so much for everyone who came to join us today. We love these demos, and we hope to see you all again real soon. Bye-bye.